How often have you pondered over the limitations of our current energy sources? Let's take a moment to consider their drawbacks. Fossil fuels, for instance, have a hefty environmental price tag. They are responsible for a significant chunk of the greenhouse gases we pump into our atmosphere every day, driving climate change and polluting our air and water. Then there's solar and wind energy, heralded as the champions of renewable sources. While they do offer a greener alternative, they're not without their own set of challenges. Their supply is inconsistent, dependent on the whims of weather and daylight. And let's not forget about the geographical limitations. Not every place on Earth is blessed with strong winds or ample sunshine throughout the year. This leaves us in a bit of an energy conundrum, doesn't it? We need a reliable and efficient source of power that doesn't compromise our planet. And in this quest, we stumbled upon the concept of nuclear batteries. The idea of a nuclear battery wasn't a sudden brainwave, but a product of years of scientific progress. It's a story of relentless pursuit, of daring to dream beyond the ordinary, and of a collective effort to reshape our energy future. The journey began when scientists started exploring the concept of harnessing the energy produced in radioactive decay. They were inspired by natural phenomena such as the heat generated by decaying isotopes within the Earth's core. This led to the idea of a nuclear battery, a device that could convert the energy from decay directly into electricity. The principles involved are fascinating. It's all about capturing the kinetic energy of alpha particles or beta particles emitted during radioactive decay and converting that energy into an electrical current. This process, known as radioisotope thermoelectric generation, was a groundbreaking concept in the world of physics and energy production. The first prototype of a nuclear battery was born out of these principles. It was a humble beginning, a small device that could barely light up a single LED, but it was a giant leap for mankind. A proof of concept that the impossible could be made possible. Throughout this journey there were key contributors and breakthrough moments. Names like Henry Moseley, who discovered the concept of atomic numbers, or Marie Curie, who pioneered research on radioactivity, are etched in the annals of this technology's history. Then there were institutions like the Massachusetts Institute of Technology, where the first viable nuclear battery was developed. Each played a crucial role in turning this idea into reality. But the story of the nuclear battery isn't just about its invention. It's about the challenges overcome, the failures turned into lessons, and the relentless pursuit of innovation. It's about how an idea, born from the observation of natural phenomena, could evolve into a technology capable of powering our future. The invention of the nuclear battery was truly a milestone, but what does it bring to the table? As we move forward, we'll delve deeper into the power of nuclear batteries, their potential applications, and the challenges we face in making them a part of our everyday lives. Nuclear batteries are not just another energy source, they are a revolution. These powerful devices are designed to provide energy in places where traditional batteries would fail, like the cold depths of outer space or the searing heat of a deep-sea vent. So what makes nuclear batteries special? For starters, their lifespan. Unlike the batteries in your laptop or smartphone that may only last a few years, nuclear batteries can continue to produce power for decades, even centuries. This is because they rely on the slow decay of radioactive isotopes, a process that takes a really long time. Next, let's talk about energy density. Energy density is a measure of how much energy a battery can store for its weight. Here, nuclear batteries shine brighter than any other. They can store 1,000,000 times more energy than a standard battery of the same weight. This makes them perfect for applications where weight is a critical factor, like in spacecraft or underwater vehicles. Now how about reliability? Well, nuclear batteries don't have moving parts. They convert heat or radiation directly into electricity. This means there's less that can go wrong, making them incredibly reliable. In fact, nuclear batteries have been powering our space probes for over half a century without a hitch. But how do nuclear batteries actually work? In the simplest terms, they harness the energy released by radioactive decay. When a radioactive isotope decays, it releases radiation. This radiation can be captured and converted into electricity, providing a steady stream of power. It's like having your own personal mini power plant. So, nuclear batteries are long-lasting, energy-dense, and reliable. They are perfect for applications where other batteries just can't cut it. But it's not all sunshine and roses. As with all technology, nuclear batteries come with their own set of challenges. Nuclear batteries are indeed a game changer, but like every invention, they have their fair share of challenges. Despite their potential, nuclear batteries face certain hurdles on the path to widespread adoption. Now let's delve into these challenges. Safety is of course a top concern. Nuclear batteries, by their very nature, use radioactive isotopes. While these isotopes are encased in a protective shield to prevent harmful radiation leaks, the risk, however small, cannot be completely eliminated. Moreover, in the event of an accident, cleanup and containment can be a complex and costly affair. Then comes the issue of disposing of radioactive waste. Nuclear batteries produce waste that remains radioactive for a considerable period of time. Managing this waste and ensuring its safe disposal is a challenge that can't be overlooked. The third major hurdle is the high cost. The production of nuclear batteries involves complex procedures, the use of rare materials, and stringent safety measures. All these factors contribute to a high price tag, which can deter widespread adoption, at least for now. However, it's not all doom and gloom. The field of nuclear batteries is ripe with ongoing research and innovation. Scientists are exploring safer and more efficient isotopes. Research is also underway to bring down the cost of production. For instance, there's a push to develop methods to recycle nuclear waste from power plants to use in batteries, which could help reduce both cost and waste. The future of nuclear batteries is promising, to say the least. Their potential applications are vast, from powering deep space missions to providing reliable energy for remote installations and even electric vehicles. As technology progresses and we learn to better manage the challenges, nuclear batteries may well become a common feature of our energy landscape. The journey of nuclear batteries from a mere concept to a reality is an inspiring tale of human ingenuity and perseverance. The road ahead is fraught with challenges, but the potential rewards make it a journey worth embarking on. After all, in the quest for sustainable, reliable, and efficient energy solutions, every step forward is a step towards a better future.